Nailed it! Oh, you're back. So, in today's lesson for grade 11 mathematics, we are going to be dealing with graphs. And as sure as I can guarantee and bet for $1 million in all of your question papers in grade 11 matric and forever and ever for all of time, you always get graphs. So, let's get started on this example. So, starting on this example, we've got a parabola and we've got a straight line equation, which I've actually, on this side, denoted as g of x, where g of x is x minus 4, which is this positive sloped straight line, and you've got f of x, which is this parabola, and it's upward facing. So the simple questions that they might pose to you is, 1, find all of the points listed in this example. So we're going to start with 1, which would be find the distance between point P and point Q. Then it might be find what the coordinate of point V is. Thirdly, it might be find the intersection points between the parabola and the straight line equation, which would be R and Q. We're going to delve into that, solve for all of these points, and unpack it and really nail this question. So solving for the parabola and the straight line equation we have, the first question that we're given is to find the distance between P and Q. So if you're not sure where P and Q, take a look back in the video. They are the x-intercepts for f of x along the x-axis. And because it's a parabola, we know that the points where it intersects the x-axis would be the roots of this equation. So the first thing we're going to have to do is factorize f of x and find out where it is equal to 0. So essentially where f of x is equal to 0. So we could say x squared minus 2x minus 8 equals 0. And this is a normal quadratic equation, so we would want to factorize it. So we'd have x equals 0. Therefore, how could you factorize 8? Which would be 2 and 4, 8 and 1, but you'd want your b term to be minus 2. So it seems like you'd need 4 and 2. But because the c term's negative, one of these signs needs to be negative, so we'd make it minus 4, and we'd make this positive 2. Therefore, we know point P and point Q. Therefore, P, the coordinate of P needs to be, x must be equal to, because it's on the left-hand side of the y-axis, it's going to be a negative value. So x must be minus 2 and 0, and Q, coordinate must be positive 4 and 0. So what would the length of PQ be? Well, it would be 2 units plus 4 units, which would be 6 units. And now you've done and you've solved the first part of this question. And although the question papers that they phrase are trying to test your understanding, they might have asked to calculate the length of PQ, but essentially they're asking, find the roots of this quadratic expression. So you've seen this before, but now they're asking it in a graphical form. So don't get scared when you do get these questions. It's the same flavor applied in a different way. So the next question they might ask you is to deal with the straight line equation function g of x. And they might ask you to find out point V, we can see, is the point where g of x cuts the y-axis. So it is the y-intercept, where the x value, have x, let's have y, the x value is 0. So you already know the x value, you're just trying to find out what's the y value. So you would therefore want let x equal to 0 for g of x. Therefore, g of 0 must be equal to 0 minus 4. Therefore, g of 0 must be equal to minus 4, which is equal to your y value. So now the coordinate of v must be, well, you know that x is 0, and the y value, you found it out to be -4. And you solve the second question by simply understanding where v is on the x and the y axis for g of x. So the next thing in your line of questioning that they might ask you, because you've dealt with the quadratic function and you've dealt with the straight line equation, they're most likely going to ask you for your third question is to find out where are these intersection points on the graph. Well, it would be at point R and point Q. So you know where Q is already, which you find out to be in the earlier question, but now you need to solve for where point R is, which would be the intersection point between these two graphs. But if I had to think about the lesson that I showed you before on simultaneous equations, you've got two equations, two unknowns, you're solving a simultaneous equation. Having this, we want this to be equation 2 and g of x to be equation 1. Essentially, you want g of x to be equal to f of x to find out the intersection point. So you could have x minus 4 equals x squared minus 2x minus 8. Because these are all equal to y, and g of x is equal to y. Let's actually separate that. Because now you find out where's the y values that they intersect. You already know that it's at point Q, but you're now trying to find out what the y value is for point R. So, making these two equations equivalent to each other, you'd want to make it into the standard quadratic form. So if I had to take everything over to the right hand side, I have 0 is equal to x squared minus 3x, and it would be minus 4. Right? And actually, just so your brain wraps it around, I'm going to swap these two sides. So you'd have x squared minus 3x minus 4 equals 0. And this is a standard quadratic expression that you can easily factorize, which would now be x brackets x equals 0. You can see your c term is negative, and you can also see your b term is negative. So you know to get a result of 3, the factors that you would use is 1 and 4. You'd want your highest value to have a minus sign, and you'd want your lower value to have a positive. So x must be equal to 4, or x must be equal to minus 1. So now that you found these two x values, you can substitute x equal to minus 1 back into g of x to find out what the equivalent y value is. So g of minus 1 is equal to minus 1 minus 4, which would be equal to minus 5. So what would the r value now be? It would be r is minus 1 and minus 5. And then you solved your third question by just simply following the rules of a normal simultaneous equation, making equation 1 equivalent to equation 2, and easily simplifying the expression to find out the resultant intersection points, or the x values, and then easily substituting one of them back into g of x to find out what the coordinate of r is. These simple methods that you learn in simultaneous equations is the exact same application in graphing. And now for the last two questions, these are more intuitive based questions on the graphs that I want you to look at the graph, and we'll go through how to answer these questions in our mind. So my humble assistant, bring in the board. Oh, my humble assistant is not doing a great job today, but it's okay. The last question I wanted to pose to you to have a think about is, I want you to tell me where the x values for f of x multiplied by g of x is less than or equal to 0. Where on this graph does this inequality hold true. So at every point that you go here, you've got g of x multiplied by f of x, g of x multiplied by f of x, g of x multiplied by f of x. Where does it hold true such that the product of these two y values will give you a value less than 0? So if you really had some thought behind it, you know that you'd want it to be over here at point Q, because it's going to be 0 times 0, which will give you a value equal to 0. So you already know it happens at point Q. You found out the earlier coordinate for point Q. Another thing that you need to check for is the product of these two, which would be, you'd want a negative times a positive, because you'd want it to be less than 0. So where are the y values negative and positive for these two? So it would have to be somewhere, because you know the y values are negative everywhere below there. So it would either need to be somewhere after point P. Because if you move to the left, on the f of x graph, it's going to be a positive y value, because it's above that part of the axis. And g of x is negative, so you're going to have a negative number multiplied by a positive number, which would give you less than 0. So it would be anything that is to the left of point P and the point number Q. And that is how you can and that is how you can intuitively solve this inequality, just by inspection of the graph and analyzing the product of these two functions as you move from right to left or from left to right. So in today's lesson, we covered the simple topic of graphs. I know I haven't covered everything, but I wanted to really zoom in on just straight line equations and dealing with parabolas, intersection points, finding the points on a graph and where they meet. Because a lot of the questions that you get asked are very similar, just posed slightly differently. And understanding that looking at the graph and understanding the behavior tells you so many things about all of the questions you're trying to solve. If you got to this point, well done, great job. Drop a section in the comments what parts you enjoyed, what parts you didn't like. If I went through it too quickly, too slowly, if you want more examples on graphs, if you want to have hyperbolas or straight line equations, dealing with trigonometric graphs or trig graphs, let me know, drop a comment below. It helps us know what more content and what more examples you'd like us to cover. So thank you for watching, really appreciate it, and honestly, thumbs up to you.